Today is lesson 7.3, the Pythagorean Theorem. The essential question is, how do you use the Pythagorean Theorem to find the missing side of a triangle? Key ideas. Sides of a right triangle. The sides of a right triangle have special names. The first one we're going to talk about is the hypotenuse. The hypotenuse is the side opposite the right angle. So here you have the square that represents the right angle, and opposite of that is this green line here, which represents the hypotenuse. This is always represented by the letter C. Then it says the legs are the two sides that form the right angle. So you have leg A and leg B. The Pythagorean theorem. In words, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Algebraically, it's simply a squared plus b squared equals c squared. Example 1. Finding the length of a hypotenuse. Find the length of the hypotenuse of the triangle. So we're going to start by writing down our Pythagorean theorem. So that's a squared plus b squared equals c squared. I'm going to make this a and this b. And if you chose to do the 12 as a and then the 5 as b, that's fine. You're still going to come out with the same result. So let's plug in our numbers. So 5 squared plus 12 squared equals c squared. And we're going to try and simplify this. So we have 25 plus 144 equals c squared. That's going to give us 169 equals c squared. And we still want to isolate c, so remember to use inverse operations. So we're going to have to square root both sides in order for our square and our square root to cancel. Okay, then we're going to get c equals, what's the square root of 169? Good, 13. So 13 meters is the length of the hypotenuse, c. Go ahead and pause the video and give these a try. So here it says, find the length of the hypotenuse of the triangle. So we're going to use the same method that we learned in example 1. A squared plus b squared equals c squared. I'll make the 8a and the 15b. So we have 8 squared plus 15 squared equals c squared. Here we're going to have 64 plus 15 squared is 225 equals c squared. Go ahead and simplify the left side by adding up those two numbers to get 289 equals c squared. And then, of course, we're going to square root both sides so that we can isolate our c by canceling out the inverse operations. And then when you get the square root of 289, you should have 17 feet. Number 2, we have fractions here. So you're going to have, I'll make this one a and this one b. A squared plus b squared equals c squared. So we have 3/10 squared plus 2/5 squared equals c squared. With fractions, you want to square the numerator and denominator separately. So we're going to have 9 over 100 plus 4 over 25 equals c squared. Okay, let's go ahead and use common denominators to add our fractions together. So then we're going to have 25 over 100 equals c squared. And now we want to isolate our c by taking the square root of both sides. So our inverse operations cancel out, and that leaves us with 5 over 10, or 1/2. So it's going to be 1/2 inches for the hypotenuse. Example 2. Find the missing length of the triangle. So here we're looking for A. We're not looking for the hypotenuse C. This is our hypotenuse, and it's important to label it correctly because C always has to be the hypotenuse. That means this leaves the blue 2.1 centimeters as our B value. So again, start off with your Pythagorean theorem. A is the unknown that we're looking for. B is 2.1 centimeters, and C is 2.9 centimeters. So A squared plus 2.1 squared equals 2.9 squared. And let's go ahead and simplify all our numbers. So we're left with A squared plus 4.41 equals 8.41. And we're trying to isolate the A squared, so we have to use inverse operations and undo our addition by subtracting on both sides. Okay, so this goes away. Bring everything else down. A squared equals, we are subtracting 4.41 on both sides, so we get A squared equals 4. And then you're simply going to square root both sides to isolate your A, because the inverse operations cancel each other out. And then you're going to get 2 centimeters. So the leg A measures 2 centimeters, and think about it. Is it reasonable? Yes, because it's still shorter than the hypotenuse, and it's very close to the 2.1 centimeters, the other leg. Pause the video and give these a try. Number 3 is 34 yards for the hypotenuse, 16 yards for leg A, and the unknown is B. So we have 16 squared plus B squared equals 34 squared. Go ahead and simplify your numbers. So 16 squared is 256. And then 34 squared is 1,156. We're going to subtract 256 on both sides to isolate our B variable. We get B squared equals, subtract 256 to get 900. And then you're going to square root both sides of your equation to isolate your B. And when you square root 900, you're going to get 30 yards. Finally, number 4, you're looking for A. So again, we start with A squared plus B squared equals C squared. So that's A squared plus, this has to be my B and this has to be my C because we know C is our hypotenuse. 9.6 squared equals 10.4 squared. So go ahead and simplify your numbers. We get 92.16. So A squared, plus 92.16 equals, and then 10.4 squared is going to give you 108.16. All right, so we want to subtract 92.16 on both sides to isolate our variable. And that leaves us with 16. Now, we still want to isolate our A by undoing the square. So we have to square root both sides. Whatever you do to one side, you must do to the other. Remember that. To get 4 meters.